Hi everyone, Professor Ullman here. I'm standing here in front of this gigantic triangle to tell you about trigonometric substitution, which is going to make extensive use of triangles. Now, I want you to notice something about this triangle. If you look at it, there's something kind of wrong with it. I'm going to cover up the top of it so that you can see. If you notice, the left arm of the triangle appears to be heading backwards into the sky. If you look at the way that the vertex of that vertex of the triangle looks, it's clearly heading backwards. But if you look at the right arm, it's heading forwards toward us, and yet somehow they meet at the top. This is an object that apparently cannot exist, and that's why it's actually referred to as an impossible triangle. Now, you may wonder how this can be. The answer is the object doesn't really look like this. This is what the object actually looks like. Now, I know you're looking at this and saying, wait, that's not the same object, or maybe it's on hinges, but no. What you see here is actually the fixed appearance of the object. The idea that it could look like this is purely an optical illusion when you happen to look at it at exactly the right angle. This object is called an impossible triangle, or a Penrose triangle, after the mathematician Roger Penrose. He described this structure as impossibility in its purest form. In fact, you may have seen something like this, and I'll show you where. If you've ever seen this drawing, the Escher waterfall by the artist M.C. Escher, what you may not have noticed is that it actually has built into it two impossible triangles, at least two. There are actually several impossible triangles. And if you look at the drawing this way, what you can see is that the water appears to be flowing both up and down at the same time, and that's achieved through the use of impossible triangles. What does any of this have to do with trigonometric substitution? Well, we do make a lot of use of triangles, but other than that, absolutely nothing. I just thought it was a fun introduction to the use of triangles, which we will use in trig substitution, but please make sure that you use regular triangles, not impossible triangles. So let's see how triangles are used in trigonometric substitution over the next couple of examples.